Okay, so good morning, everyone. So I want to apologize to start things off. I will not be able to teach class live today. I will be at an English professional development meeting, so there will not be a live class. However, that still doesn't excuse us from the work that can still happen. So if you go ahead and click on Materials and Unit 2, you will see I have added an assignment. So this is going to help us when I see you next on Wednesday actually have a discussion about what it is you thought was happening from last week. So a little bit of a recap of what we did last week. So if you want to do me a favor and go ahead and open up 2 pages 23 and 24 in your notebook. So why don't you go ahead and pause the video right now while you're opening up to pages 23 and 24. So what I want you to pay attention to is this part here. Is right here we had a opportunity when we looked at the balancing knives and bottles trick. So that was what we did the very, very tail end of class yesterday, or last week is when you had the 3 cups and you used the 3 knives. And then what you were able to do was position all of the knives so that they were able to balance and then eventually hold a cup up, right? And so we didn't really get a chance to do this, but right now I want you to draw a model. And I want you to draw a model that shows the science behind what you thought was happening. How do you think the knives are interacting with each other? How do you think the bottles play a role? And how do you think a cup is able to stay on top of all of this, right? There's nothing in the center down here. Remember, the cups are all on the outside, in this case, the bottles. But try your best to come up with a model, right? So this model is a drawing that shows the science behind what it is you are seeing, or in this case, what it is you all did last week. So the knives are really important. The bottles are also really important in your model. So you want to show how the bottles, and the knives were interacting to hold all of this up. Okay, so where are you going to do that? That is going to be on, so your notebook page right here. So just as a heads up, this is what we have so far. So 1, you crushed the egg. 2, you have the cup and the coin trick. But 3, now you have balancing act and bottles. So go ahead and draw your model in down here and see what you can come up with to show the science behind it. And so go ahead right now, pause the video while you work on creating your model. And then you can unpause the video when you are done making the model. Okay, so hopefully by now you are all set and good to go with a drawing down here. But what we're going to do is we're actually going to go back to these 2 models up here. So we're going to look at the model you made for crush and egg, but also the model you made for cup and a coin. So let's look at the crush and egg first. So we're actually going to add something to it. So what I'm going to have you add to your model can be found in Schoology. So let me go ahead and open back up Schoology. So when you click on this assignment right here, it will take you to this PDF here. Now this PDF is here to help you think more about your models. So when we go ahead and open up this PDF, this is where it will take you. Now, what it's going to have you go back to is this. Think back to these 2 questions. I'm going to have you just write down the answers in that space on your notebook page as to why you think it was so difficult to break the egg. I'm now realizing this says the word do. It should say why it was so difficult to break the egg. And also, how do you think the shape of the shell played a role in your ability to not break the egg? So right now, I want you to go ahead and just quickly answer these 2 questions in this space right here where it says force in the crush and egg part, because this will help you add things to the model. Because as of right now, this is not a model. This is a drawing of an egg. I myself have not added things to it because I want you to have the ability to add things to it. So one more time, this is what you're doing. Just where the questions are highlighted, why do you think it was so difficult to break the egg? I know this should say so. And then last but not least, how do you think the shape of the egg played a role in your ability to not break the egg? So go ahead and jot the answers to those 2 questions somewhere in this space here. And that should give you a clue as to what you need to add to this picture. Right? This picture alone does not show what you did. It does not show the science as to why the egg didn't break. Even if you're not sure, I want you to take your best guess. So what things can we add to this here that will better display what was happening? Okay, so why could we not crack the egg? Many of you were squeezing and squeezing and squeezing, nothing happened. So there was something that had to do with the egg and the shape of it as to why we couldn't break it. So I want you to add something to this model. Add something to your own model. Okay? And then last but not least, we're going to get into the cup and the coin. So go ahead and pause this video while you finish up your work with crush and egg. Now that you're done working with crush and egg, I'm going to have you go just to the cup and a coin. And I'm just going to, these questions are here to help you think about this more, right? What was the difference you noticed when we pulled the card slowly versus when we pulled the card quickly? And what forces do you think had an influence on the card and the coin? So this question here, the ones highlighted, this is the one I want in your notebook because this is important. So what are you going to add to this model here? Just your answer to this question here. What forces do you think had an influence on the card? So go ahead, write down what you think influenced the cup, the coin, and the card. Really, it was the only thing that were moving were just the card, which was this rectangle here, and the coin, which is this brown circle right here, which was like the penny that we used. But what forces do you think influenced the card and the coin? And just jot them down here. And then I want you to add them to the model. How can you show what forces were happening? How do you want to show them? It's totally up to you. But how can you show how certain forces influence the card and the coin? And if you're not sure, take your best guess. Remember, it's not graded based on correctness. It's graded based on effort. So do you have these ideas? The only way that you learn is by looking at your ideas and how they've changed over time. Okay? So here are the last two models that we did at the very tail end of class. Now I want to go to the first models we did. So once you're done adding to the cup and the coin, go ahead and pause, or actually right now, pause the video. Pause it so you can add things to this model here. And once you're done, you can restart the video again. All right, the last thing I'm going to have you look at today is going to go back to the first two models we made. So here, this was the long track versus the short track, and then this was the Galileo track, right? So what I have here, these are drawings, right? They're just drawings of what happened. Here, the short track, the ball was rolling down the track. That's fine. You also have the long track where it's clearly the track is longer than the short track. And I can show that the ball is moving to the right. But what I'm missing is I'm missing the science, right? These pictures just show me what, right? They show me, oh, a ball rolled down a track. Okay, that's what your drawing shows. Cool. But it's missing the why. So we know on the long track, the ball made it to the end much faster than the short track. So how can you show that this ball down here is moving faster? Do you know why it's moving faster? That's what I want you to add to these models. Find some way to show that, yes, on the short track, the ball is moving slower. And on the long track, the ball is moving faster. And then even if you're looking to go a step further, how can you show why the long track would move faster than the short? So go ahead, pause this video as you work on adding something to your model, because this picture, if this is all you have, it's not enough. This picture just shows what happened. It does not show the why. Okay. And even if you're not sure, that's fine. Remember, it's okay. But I want to see your ideas, and I want to see how you can make these models and push them further, because these only show the what. They don't show the science behind it. They just show a ball moving to the right. It doesn't show me which ball is moving faster. That's for you to figure out. That's for you to add to this model. And if you can even show me the why you believe that one ball is moving faster than the other. What is the difference between these two drawings? How can you show the difference in one ball moving faster, or the why behind one ball moving faster than the other? So go ahead, pause the video while you work on your models. And last but not least, we are at the Galileo track. So remember, this track here, once we dropped the ball from the left side, it rolled all the way up to the right, and then it rolled all the way back down. And then I dropped it from the right side, and it rolled all the way down to the left, and then it rolled back to the right. So really, there was no difference. Doesn't matter which side you dropped it from, you got the same results. And so what I have here is I have a bit of a drawing. It's a model, right? Shows a ball moving to the right, because I dropped it from the left side here, going to the right. And then over here, I dropped the ball from the right and moved to the left. That is what this model is showing, but it doesn't show me why the ball didn't go flying off. Some of you might have expected that the ball would have rolled off. Doesn't matter what side I dropped from, you're like, the ball's going to go off. The ball never did. There's a why. Why do you think the ball never did? So what I want you to do, what I'm going to have you do, is add the why. What do you think as of right now? Remember, it's okay to be wrong. There's no penalty for being wrong. But there is a penalty if you don't show your ideas. Try to come up with an explanation. Try to show something and add something to this. What about dropping the ball from the left side doesn't allow it to go off? What about dropping the ball from the right side doesn't allow it to go off to the left? We get the same results either way. One side is 3 times longer than the other. So there's got to be some sort of science behind what we're seeing. So that's the why. So I need you to go ahead and see what you can add to this model here before you submit this as an assignment. So go ahead, pause the video while you work on adding something, the why, to this model. All right, now that you are done worrying about adding things to the model, you are now ready to submit the assignment. So this is the last thing I need you to do for today, because we will discuss this when I see you all on Wednesday. So in this space here, you are going to go ahead and you are going to scan in both pages. Both notebook pages need to be scanned in. All right, so that means you are scanning in, number 1, this entire page here, Cool 24. You are also scanning in page 23, which is what we just talked about here. So you're scanning in both documents. If you can, try to put it in one note or in a note, so that way I can see both of them. If not, it's not the end of the world, but it makes my life a lot easier. So go ahead. That's all we're working on for today. So please rework and add things to those models, and we will discuss your work and what you've done when I see you next on Wednesday.